Hey, welcome back. So as you know, I'm a huge fan of the Qwen series of models. In fact, the Qwen 2.5 Coda model has featured many times on this channel because it is a super workhorse of a model for its size. But I am super pleased to see this week that Alibaba released the Qwen QWQ model, which stands for Qwen with Questions, and it is their reasoning model. Now, it has been around for a bit, but what's different this time is it's hit state of the art and it's actually comparable to DeepSeek R1. And believe me, this model is incredible. But what makes it super incredible is its size. It's only 32 billion parameters, which means you can run it on your laptop using Ollama. And that's what we're going to do today. So I'm going to get you up to speed with some of the capabilities of QWQ. We'll have a look at it and we'll get it up and running on my machine. I will have a bit of a play around with it on the internet as well. And you'll get an idea of its capabilities. But believe me, it is so cool to have a state-of-the-art model that you can actually run on your machine. So with that being said, let's get started. Alrighty, so before we start looking at it on Ollama, one of the things that I want to do is just show you it running within a browser. So actually you can access the model for free via chat.qwen.ai. We'll just bring that up. You can log in, sign in. I mean, obviously from a privacy perspective, you decide what you need to do of how much confidential data you would put in there. But I would say that any of the internet models, you really shouldn't be putting your confidential data in there. But let's kind of get started here. Now, the first thing you can see here is that it selected Qwen 2.5 Max, which is their sort of base model, super powerful model. I should cover it on the channel at some point. And that's maybe one of the first things that I've got to say about all reasoning models, which is they're all built upon good base models. So if we look at the Qwen QWQ, its base model is the Qwen 2.5 Max, which again, they released a few weeks ago. And if we look at the DeepSeek R1 model, its base model is DeepSeek V3. Again, there was a lot of hype around that as well. And the key thing about the reasoning models is the magic happens in the post-training phase. So the pre-training phase is the creation of these base models. Once you've got the creation of a base model, then you're going to fine-tune it to give it its personality and be able to answer questions and handle all the benchmarks. That's where reasoning happens, and that's where all the reinforcement learning and verifiers and all that, which I've covered in previous videos. So to make the Qwen model work, the QWQ model work there, I'm going to have Qwen 2.5 Max here, but I need to make sure that this thinking box is selected, and then I can ask it questions and it will be the QWQ model. So I'm going to ask it a math question, really simple. What's 254 multiplied by 752, blah, 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 blah. The reason I'm going to ask that is kind of most non-reasoning models are going to get that type of question wrong, but we're going to ask that. And then it's going to go off. And you can see straight away that it goes into this thinking mode. Again, I'm going to show you this in Ollama in a second. But it's going to do this. And again, if you've seen DeepSeek R1 before, you will recognize that this is a really chatty model. And again, if I compare this to something like, let's go to ChatGPT for a second, and we'll pick maybe the O3. Let's pick the O3 mini model and we'll ask the same question and we'll compare the chain of thoughts, and then we'll do the same with DeepSeek R1 in a second. So it's going to go reason. Notice, and again, be aware that OpenAI don't show all the chain of thoughts in that sense. They do summarized versions of this. But again, I think that you can see the speed there. It's only a few seconds. It came back with the answer 191005. But this is a clean chain of thought. Let's break down step by step, multiplication, subtraction, parenthesis, and then the addition here. Again, if we look at the Qwen model, it's kind of got more of that DeepSeek feel. So you see there, okay, let's see, I'm going to do this, blah, blah, blah. It's not as structured as the OpenAI models. And I think that's something to kind of be aware of. It's got more of that sort of DeepSeek feel. So if we just go onto deepseek.com for a second, again, I'll select the DeepSeek R1 here, and we'll ask it the exact same question. Again, there's the same thinking model, and it's going thinking. And then we'll see the chain of thoughts sort of stream out in a second. But what you are going to see is those chain of thoughts are very kind of free flow and not as structured as the OpenAI ones. And it's just going to go round and round and round. So it's kind of like a panicked kid at a math exam. So it's doing its calculations, and then it just comes at it from so many different angles, and it creates so many tokens. So as you can see there, DeepSeek R1 has finally came back with the answer there, and it's run through the calculation multiple times. In fact, up here, it's kind of sort of made a mistake there at 191008, but then it comes at it from a different angle. It gets 191005, and it's going round and round in circles, and eventually it comes back with the answer, which is 191005. And then notice this little box here. You see that little box, 191005? Now, if we come back into Qwen for a second, it will have finished by now. Same sort of thing. It's going round and round. It's doing it from multiple angles. It's got 191005 there, and then it's calculating it again, and then it calculates it again. And then eventually it comes back with the right answer. And again, there, notice the box there, right? 191005, right? Exactly the same as we've got over here, 191005 in a box. So again, very, very similar. And there's a reason for that, because if we actually go into the blog post of Qwen with Questions, you can see here they've actually followed a very, very similar path, the DeepSeek R1. If we just take a look at the paper here for a second, you can see we're introduced QWQ32B, a 32 billion parameter model that achieves performance comparable to DeepSeek R1, which boasts 671 billion parameters model. So you can kind of see the difference there, the size difference between DeepSeek R1 and Qwen 32B. I can't run the full DeepSeek R1 on my machine. Well, maybe I could. I haven't tried it, but it's just such a huge model. I mean, it's just massive to download in the first case. I think it's something like 650 gig or something ridiculous. But it's a mixture of expert model with 37 billion parameters activated. So if you don't know what a mixture of expert model is, basically it is you have a huge model, but it's kind of sliced up into these individual experts, and only some of the experts are activated at any time to answer a question. So you can have a really large model, but you're only activating some of these smaller experts to answer questions. That keeps the kind of size down there. But what you can kind of see here is with QWQ is it's not a mixture of experts. This is a full dense model at 32 billion parameters, and it's smaller than even with just the sort of active portion of DeepSeek R1 enabled. So this is tiny model. I mean, it's not tiny, it's 32 billion parameter model, but it's for state of the art. It's incredible, right? And again, you can see here that it's saying it's pre-trained on extensive world knowledge, but as you can see with reasoning, it's going to be focused on math and coding capabilities. But what's really nice about this is it can utilize tools, so it can do function calling, and we're going to test that out a little bit later on as well. It's got some of the benchmarks in here. Again, I don't really trust benchmarks, but I'm more of a vibe code kind of person, but you can kind of see there the Qwen model and DeepSeek R1 is really on par with each other anyway. And again, if we look at this, talk a little bit about the approach. They say we begin with a cold start checkpoint. Now, I have a video on sort of cold starting already, and I take a tiny model. In fact, it was the Qwen 2.5 Coder model, and I got it up to doing pretty complex math with very, very small amount of instruction students. So you can go check out that video to go into more detail of what bootstrapping is. But effectively, it is you are teaching the model the good structure, how to answer those questions, right? So it understands how to do that. Remember those thinking tags? So it says thinking, and then it comes back with the final answer. And remember the box? They are the things that you would be sort of teaching it in the kind of the bootstrap checkpoints. This is how to answer math questions. Here's how to get your thinking tag so the model doesn't need to learn it. And here's how to box an answer on there. And then they're using reinforcement learning with outcome-based rewards. So again, in one of my other video, I show how reinforcement learning verifiers work, where you can kind of have verifiers for different rewards. Typically, what DeepSeek R1 used for their verifiers is that they used a format verifier to check that it created the right thinking tags, and then the kind of final answer in the same format every time. And then they would have a verifier to called an accuracy verifier, which would check the result of the math function. So actually, if we came back into DeepSeek R1, you see where it says final answer 191005. This is basically a piece of markdown called a box. And then the accuracy verifier will look for a box in the answer. So it will look for the box tag, and then it will take whatever answer is in here, 191005, and then it will compare it against the real answer that it's calculated in the data set. And therefore, that's how the kind of reinforcement learning part works. Again, I have a whole video video on verifiers, and you can go check that out. But more importantly here, you can see that Qwen is doing the exact same thing with QWQ. They've got the box verifier, and they're doing the exact same verifier reinforcement learning technique. So again, you can check out that video there. And then they're scaling it specifically for math and coding. Same thing works for coding tasks. So rather than it be math in a box, you can do the exact same thing. And then this time you can have unit tests for whatever data that you've generated in the data set. So again, so we're relying on traditional reward models. We utilize accuracy verifier for math problems to ensure correctness of final solutions, and code execution server to assess whether the generated code successfully passed the predefined test cases. Exactly what I said there. And then as training episodes progress, performance both domains shows continuous improvements. And then after the first stage, we add another stage of RL for general capabilities. It's trained with rewards from general reward model and some rule-based verifiers. We find this stage of RL training with a small amount of steps can increase the performance of other general capabilities. So again, if you check out my video on fine-tuning, you see that there's this idea of a general data set. So when you fine-tune a model for a specific task like math or coding, the model forgets how to perform more general tasks. So things like summarization will look like a coding problem. Things like creating limericks will look like a coding problem. So what you need to do is almost have this kind of generic data set to reteach the model how to do generic tasks in the same way. And again, they're sort of saying the same thing here. So back to my actual point. Why does the model look like DeepSeek? Yeah. So back to my original point, why does the Qwen model look like the DeepSeek R1 model, which is they took their base model, which is the Qwen Max model, where DeepSeek had their V3 model, and then effectively they've trained it in the exact same way. They've done cold start data to get the model kicked off in the right way and do it properly. And then they've used reinforcement learning with verifiers to then sort of train the model on producing accurate results for both math and coding. So you're going to see good results within math and coding. So that's kind of why they're sort of accurate. Now, as I said before, if I want to, I can get this model up and running on Ollama. So if we go to ollama.com for a second, and then you see in library there's QWQ available at the very top. So if I want to get it running, you can see I've already downloaded it. So you can just do Ollama pool QWQ. It will give you a quantized version of that model. So now that we've done that, let's just run the model, and then we're going to ask it the exact same question. What's 254, blah, 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 blah. And you see it's a fairly fast model here, and there's the think tank. So remember what I said before within the here, where it's generating these little thinking completion tags. The UI is just looking for the think tags, and then it's wrapping everything within here. So it's going to go off there, and it's going to sit and do the calculations. Now, this is a quantized model. You can run the full model against this. How much memory do we need? I'm going to run a thing called MacTop for a second. And you can kind of see here memory usage. And I think I started at around 17 gig just for running the general operating system here. But you see my memory usage on my Mac is about 41 gig at the moment. So again, this is reasonable if you've got a decent sized Apple Silicon Mac. You can probably get this running on your machine with one of the quantized models. Actually, I could run this with one of the non-quantized models if I wanted to. So it would run a little bit slower, but it would fit within the memory. And you can see it's going off there. It's doing a decent speed there, but and you can kind of hear it's sort of fairly tanking my GPUs. I think one of the things I would say about this is because of the wordiness of the tokens, this is probably too many tokens for too slow of a speed to be able to really utilize this on your machine for major tasks. I think you would just get frustrated very, very quickly. But the reality is it is pretty cool to have a state-of-the-art model running on your machine. What I would love to see with Qwen is that I would like to see either a slightly smaller model, maybe in the kind of 8 billion parameter range, or maybe the 14 billion parameter range. So I could get faster tokens per second than this. I would also like to see better cold starts. I like to see more structured chain of thoughts like the O3 mini model, so that it doesn't need to generate so many tokens, because I feel, and if you checked out my video on this, I feel that it takes probably too long of a time to come back with the answer. But again, it's maybe I'm being too picky here. It's just incredible to have this. Alrighty, so it's done there, and unfortunately I've ran out of generated tokens, so I probably need to update my OLLAMA settings there. But you get the kind of point. Look at the amount of tokens that it's kind of generated here. But regardless, I can do this now. Now, again, if you wanted to have a sort of chat experience running locally, you could of course use OpenWeb UI. So again, if you go to Docs OpenWeb UI there, you can kind of see here's a little bit of an explanation how to get that running. So I can just copy that, and then in my machine here, if I wanted to, I can do a Docker run. And we can just go to localhost 3000, we'll just sign in, and then what will happen is I have access to all of the models that are on my local machine. And if I select the Qwen model, and then I can say something like, tell me a story about cheese, and there you go. So it's using OLLAMA in the background, but now I've got a nice UI which is kind of useful for things like coding and all that sort of thing. And then it's going to go and create this little cheese story, and everything's kind of good. Notice that even though I'm not asking it a math problem, it is going to be doing its thinking for general capabilities such as stories, and then it's going to follow that same format. So it creates these think tags, and then it's going to output its kind of final story there. So you see it's done the thinking, it's worked out its plan, and then it's creating the story based on the plan that it's created. Now, I could go and sort of compare like a billion different math problems, but to be honest, you've seen from the benchmarks, it does a pretty good job. It does a job that is good enough as kind of the O3 models do. There's a pretty good job just as well as the DeepSeek R1 model. So I'm probably not going to spend time on that, but let's just say it's pretty good as math, or it's as good as all the other models are at math anyway. What we'll probably do a little bit of time is I'll spend a little bit more time on things like coding and just see how that looks. What I would say with the model is they are great, but most of these models struggle with things like logic and reasoning problems, and I'll sort of prove that. I'll ask it a question. We're going to play a game called Elephant in the Room. This is a game that I stole from Richard Osman's House of Games. The elephant in the room is a word that I'll choose, and then no matter what question I ask, you shouldn't say that word in the answer. Again, I know we're going to get into an argument about this being a tokenization problem, but the fact is it's a reasoning model. It should be able to handle tokenization issues, including if the word is a subword or a larger word. So if the elephant in the room is Don, and the question was which restaurant chain has golden arches in its logo, the answer would be McAlds, i.e. it's skipping out the Don part. So rather than McDonald's, it would be McAlds. So in this case, the elephant in the room is Star. And I'm going to say, who did Robert Downey Jr. play in Iron Man? So we should get Tony K as an answer. So as you can see there, Qwen's came back there. It's not quite got it. It's came back with Robert Downey Jr. Portrayed the character Tony. So the best answer would have been Tony K, but it didn't quite get there. But the good news is none of the other models have done very good at this either. Robert Downey, it came with Tony SK, so it's not quite got the star part. That's sort of O3 mini high. And then if we look at kind of Claude 3.7, it's came back with the same issue as well. So none of these reasoning models have ever really solved the tokenization problems. But again, maybe that's something kind of where it needs to go. So, but you know, Qwen's done a pretty good job on that one, but it's no better or worse than any of the other models. So we're going to do a couple of coding ones. I've done these in my other videos as well. I'm not going to sort of replay how the other models look, but let's see how this does. So I'm going to ask it to create a React app, give the latest time from an internet time service, and update in real time from the internet. Keep it in sync as much as possible. Don't use external dependence and create an AI generated donkey. Just for a sort of comparison, whilst it's doing that, we are going to ask Claude 3 Sonnet with extended thinking the exact same question. We'll just get rid of this bit, and then hopefully 3.7 Sonnet with thinking is going to do a pretty good job of this. Alrighty, so this the Claude one is really good there actually. It's got the time correct, 1803, 58:59. It's not blinking the donkey. That's the best donkey I've ever seen. And let's see how this is done. Okay, so that's pretty good. It's created a React app. So let's copy this. I've copied in the app CSS as it's sort of described. and I've copied in the clock code there. Again, pretty simple in that sense. And again, if we just open up my terminal, I'm going to do npm start, and then we'll just say run that. And here's my donkey clock. Now, the eyes aren't blinking, but that's a pretty good donkey. I mean, that's pretty much almost as good. I prefer the Claude one, but that's almost as good. All right, let's run a couple more tests. Let's come back to Qwen here for a second. I'm going to do what I call an embeddings test here. So I'm going to say, here's some code that extracts some image embeddings. And then what I'm going to say is enhance it to show cosine similarity. So it's a kind of fairly simple one here. So it really what's going on here is I've got this sort of Gina AI model here. I'm going to pass into images, and then I want to check the similarity of the model. Now, a lot of models will struggle with this. They'll end up changing the model underneath this as opposed to the version that I want, or they'll give different things. But let's see how Qwen, by the way, Claude does this perfectly. ChatGPT, the 0103 mini models do it all great as well. Let's just see how the Qwen model does. Again, I'm running this on their website at this point in time, but you are going to be able to run this just locally with Ollama. We'll just do touch test.py. We'll do a code dot, and then let's go into test.py, save this in here, and then if I do a python test.py, you are going to see, does it do the cosine similarity check? Oh, and it's failed. Okay, so I mean, just to kind of prove that point, if I come back into Claude for a second and then do the exact same question, you can kind of see that Claude's going to do a perfect job on this. And then we'll run this one more time. You can see that Claude's going to do the perfect job here, and we're going to get our similarities correctly. So again, we won't test DeepSeek there, so most models struggle with this problem anyway, but it sort of gives you an idea of kind of where that is. We'll do another one here. I'm just going to do this one here. I'm going to ask this to, by the way, this is the very first basic program written by Dartmouth. It's known as the Dartmouth calculator, and I'm just going to ask it to rewrite it in Rust. Again, but let's see if Qwen2.5 Max does this well. And actually, while I'm waiting, we might as well see if O3 Mini can do it and see which one comes back. First, we'll say rewrite this in Rust, and we'll do the same with Claude as well. We'll put Claude in thinking mode. Alrighty, so this actually came back with something, and we'll just replace my main with this, and then hopefully if we do a cargo run, we might get a working Rust program. Hey. And you can see it came back with the answer there. That looks pretty good. Let's compare it to the answer that ChatGPT gave. So we'll just put this in here, and let's run this here. Slightly different solution, do a cargo run again, and you see it came back with the same answer. So actually, really good job, Qwen. Alrighty, so the last test that we're going to perform is we're going to have a look at MCP. So I'm going to use my MCP CLI. Again, you can check out my videos on MCP. This is really just to check how good QWQ is at function calling, and we're going to do that by calling an MCP server. Okay, so before we look at the QWQ model, I'm going to bring up my MCP CLI client, and I'm going to connect up to SQLite database, which allows you to look at products. Now, initially, I'm going to connect this to GPT-4o Mini, and we're just going to say select top 10 products, kind of ordered by price. And as you can see there, it's called in the tools, it's called list tables, describe tables. So it's just doing some queries to understand what's in the SQLite database. And then it comes back with the products ordered by price. So that kind of works well with GPT-4o Mini. And then again, if I wanted to, I could run this with the Qwen2.5 Coder model. So we'll say the exact same thing, select top 10 products ordered by price. And again, you'll see the Qwen2.5 Coder model works great. And again, it's going to be super, super fast. So it's listing the tables, it's going to go and describe them, and then it's going to come back with an answer. So eventually, I mean, it's had to call list tables a few times, and that will be because it's had to kind of figure out what's going on. But you can see there it's came back with the answers. And if I want to, I can look at the kind the tool call there just to see what's went on there. So you see it's called list tables 3 times, and then it's messed around with a bunch of queries, and it's eventually got what it's actually needed. So that's pretty good. And if I look at the conversation history, you can see the actual calls there on the kind of final read query. It's got the data that it needs. You know, it's struggled a little bit, but it's came back with the answer, and I think it's done a pretty good job. So now if I then pass in the model as QWQ, and we'll say the exact same thing, select top 10 products ordered by price. Now, the good news is that the QWQ model, as you're going to see there, actually supports function calling, which is awesome. But you can probably start to see the problem already because it's going to generate an awful lot of tokens, and it's a much larger model than the Qwen2.5 Coder model. So although it supports function calling, really, is it suitable for sort of agentic stuff? And the answer is probably not, just because it's so slow and it generates so many tokens. So you see the difference here. It's calling the tools, and then we'll have a look. Once it's actually finished the answer, we'll have a look at kind of the tool history and conversation history and see what it actually generates. And there we go. It's finally came back with the answer there. So it's called the tools. You see list tables took 18 seconds, describe table 27 seconds, and then eventually the tool completion took 90 seconds alone. And then it's finally came back with the answer there. And again, I haven't separated out the thinking elements from there, but you kind of see the point. If I were to look at the tool history for a second, you see it's called list tables, describe tables, and then read query. It's done a really good job. It's got it first time, unlike the Qwen2.5 Coder model. And again, if I look at the conversation history there, you can kind of see it's made the tool call. It's got the products describe table. It's understood the table. And then it's done the read query. So if I just look at, let's say, conversation history number 8 there, it's got all the 10 items it needs to display. And then if we look at 9 there, you can kind of see there's the thinking tag, okay, for the first 10 products. It's done its thinking there. And then it says here are the 10 products ordered by price from highest to lowest. So it's done a great job. It's super smart. It's just really, really, really slow. So I don't think you would probably use that in production unless you were running on something super fast like Grok or something like that, you know, as opposed to running on my local machine as I did there. So anyway, I think that's kind of all I wanted to show today. First thing I would say is QWQ is a great model. I mean, it is comparable to DeepSeek R1. It's been trained in the same way, but it's much smaller at 32 billion parameters. Its math capability is just as good as any other model there. What's super cool is that it's got function calling capability, so it works with things like MCP, though I think it's far too slow to be able to do that, certainly on a local machine. But even then, I'm really looking forward to a smaller QWQ reasoning model that we would be able to do agentic work with function calling. So maybe I would love to see something like an 8 billion parameter or a 3 billion parameter model that is able to do the function calling elements. I think that would be super amazing. And then third thing is, obviously, it's really good at code. It is state of the art, but honestly, it's probably as good as DeepSeek R1 at coding capabilities. But I would say there's no way it's anywhere near O3 or anywhere near Claude. So I think it's done a good job. You know, it's done the kind of SVG stuff, the blinking donkey and all that sort of thing. But it kind of really struggled with the sort of more AI focused ones like the cosine similarity. So I think it's good at benchmark stuff, but I don't think it's so good on the other ones. And then for logic and reasoning, it's probably just as good as any other model out there. You know, we did that test earlier with the kind of, you know, the tokenization test. All the other models are doing terrible at that anyway. So QWQ, what a great model, 32 billion parameters. I can run it on my machine. I can run a state-of-the-art model on my machine. That is incredible. You know, I'm just looking forward to some smaller models, and then I'm looking forward to a model that has less chatty tokens and more structured tokens, kind of like the O series of models. And I think when that happens, we're going to get some real greatness that we can run on our machines. Anyway, I hope this video has been useful, and I'll catch you on the next one.